Greetings everyone. So in today's video I'll be showing a demo for the lab exercise 4.3, which is related to the problem 1, which is hotel conference room. So you may refer to the question. So first of all, we will start by solving the input followed by the process and the output. So in our case, the first input would be to get the enter choice from the user. So what we will do is we will display the options, the menu options. So you may copy paste from the question file. So we have E for enter new event, and let's put a new line, and L for list all event, and finally X for exit. Okay, and then we'll add two more new lines, and this is where we will ask the user to enter choice. So once we've displayed this, we'll need a scanf. So the input from the user is basically a character, and we're going to save it in the variable called choice. So let's declare that variable first. Variable declaration, it's char choice. Okay, and then here we display the menu options. Okay, so if you take a look at the figure 4.3, we can see that there's an option for exit, which means the user will be allowed to execute the menu as many times as possible until the user decided to exit. Okay, so we know it's the while loop. In our case, because we're going to show the menu first, so it's going to be a do while. So what I'm going to do is I'm going to type do while. Okay, and then what we want to do is basically to display the menu options. So we'll put it in the do section. Okay, so what's the condition is while the user doesn't select X for exit, right? So how are we going to check this choice? Is basically we can use the switch case. So for this, I'll leave it at the moment, or we can do it straight by actually declaring a variable status. I'm just calling it status. So what I'm going to do is that as long the status is 1, which equal to yes or okay or true, then we will keep looping. But once the choice, or once the status is 0, then we terminate. So what we're going to do is that we're going to create and declare this variable status, because we're going to declare 1 as true, right? So we will initialize it as 1, which is to represent true, and the moment the value change to 0, then we will terminate the loop. So we're going to loop this while the status is equal to 1 or true. You can use other numbers and even 0 for opposite, it's fine, but for this example I'm using it 1. Okay, so this is the condition, terminating condition. Okay, and then for the choice, since it's a menu, right, so we're going to utilize the switch case scenario. So what are we going to switch? This variable choice based on the user input. Okay, So what are the cases? In our case, because it's the char or character, so we have E, L and X. So the first would be for E. Okay, this is what we will be executing. Let's keep that for a while. Then break. We'll come back to that. Okay, and the second case would be for L. Okay, and the break statement, and then the third case is for X, and there will be a statement and break. Okay, as before, I think in programming, C programming, you have learned that we need to have a default. That is for in case that the user decided to key in values besides the cases that we want to execute, right? So we'll put in default. So what we want to do in the default is basically we want to let the user know that the input is invalid. So we will use a printf. I'm going to reuse this code. Okay, so let's keep it a new line, and we will prompt to the user invalid input. Okay, so this to let the user know that the input is invalid. Okay, and of course the break statement. So this would be the many options. Okay, now we need to figure out for the case. So we have option 1E for enter new event, option 2L for list all event, and option 3X to exit. Okay, for exit we do know that if the status change to 0, this loop will be terminated. So if the user selected the case X, we will set the value to 0. Okay, for case E, let's utilize the function. So we're going to create functions for this, which is enter new event and list all event. So let's name it enter new event. So which means if the user selected this, we'll have this function call for enter new event. And if the user selected L, we will call the function list all event. This is quite similar to display function actually. Okay, so we have enter new event, list all event, and status. Okay, so the first part of the input have settled. We get the input from the user, and then we will do the process. So let's take a look on this process. Okay, so we're going to reuse this, and for function there's three parts: function prototype, or function declaration, function definition, and function call. So this is the function call. So we're going to do the function declaration. I'll paste it there. So we'll have two functions. Okay, so this function we are just going to call, and we don't require any return, so it will be void. Okay, and we are not sending any parameters so far, so yep, we'll leave this empty. Yeah, so function declaration, and then of course the function definition or the function body. We'll reuse this again, copy paste. That's for the first function, and this is for the second. Okay, so we have two process. For this process of exit, no issue. The moment user selected X, it will switch the status and the loop will terminate. Alright, so for enter new event and list all event, okay, in our question, we have to do linked list, and as mentioned by the question, it is using insertion at the beginning. So we insert at the beginning, and we are not using array. So in this case, it will be struct. So we are going to create our list based on struct. So if we refer to the question, what is this question or problem about? Is hotel conference room. So let's create the struct, the template. So struct, and we will name it as hotel. Okay, since because it's related to hotel conference room. Okay, so what are the members or the elements of this node? If you take a look at figure 4.1, you can see there's two information actually, which is room number and event. So room number, for room number it's going to be an integer. So room number. The second element would be the event. The event, because it's going to be a text or string, so we will name it char event, and let's assume it's going to be long, so let's put in 1000 characters. Okay, and since this is going to be a linked list, and for this question we are focusing not on circular or double, it's actually singly or single linked list, so there'll be one pointer to the next node. So to do that, we have to add struct. This is the struct name and the pointer. So we're just going to name it next, so we know that it's the next, the pointer that points to the next node. Okay, so that's for the struct. And since we are not going to send any parameters here, so if you take a look at the slide for the chapter 4 linked list, we do know that we need few pointers in order to process this adding in the beginning or middle or at the end. Okay, so what we will do is we will declare as a global, okay, struct hotel. So what are the pointers that we require? The standard is basically 8 pointer. This is to indicate the starting of the list. Okay, and then we need new pointer. This is for the new node that we want to create, allocate, and then add into the list. Okay, new pointer, and then we need a temporary pointer to work on the adding and so on. So let's call it current pointer. Okay, so at this moment we just need this tree. So once we have done that, so we do know that we can start creating our list. And for linked list, there is a code where you have to dynamically create the space or the memory allocation. So I'll show that in a while. Okay, so up to this part it's done. So we will move into our first process, which is the enter new event. Okay, you can refer to the slide. The codes that is required for the memory allocation to create is basically we will use back the pointer here. So we have new pointer, 8 pointer, and current pointer. So what we're going to do is we're going to add a new pointer first. Okay, and this is where there are few parts. Okay, there'll be a first bracket, and there is something called malloc or memory allocation. Okay, and you need to let know the size. So it's size of. Okay, so these are the information that you require every time you want to create a new node. Okay, so what are we going to create? The temporary is based on this struct. In our case is hotel. Okay, so and then the size, of course we are going to refer back to this struct hotel. Okay, so now we have done this, so we know that we can create a new node. So what are the information that is required to enter new event? If you take a closer look at the question, we know that we have to put in the room number and the event. So we know there is two input for this enter new event. So we will make use of this printf and scanf. Let's reuse this code. So what I'm going to ask user to key in is basically enter room number, and we'll have to save it. Room number is integer, so it's D. Okay, where do we save? Okay, this is the part. Copy and paste this first. Template, okay. So we are going to save into this node, and we're going to access it using this pointer name. Okay, so new pointer, and then using the arrow, and we're going to save it in room number. So when the user key in the enter room number, we will save it in this element. Okay, and the second one is basically enter event name, and this is a string type, and we are going to save it in new pointer, point it to the event. Okay, so now we already have the input to be saved in this new node, so it will fulfill these two information, room number and event. But of course, at this moment, once we create this new event, we need to add this node that we have created with this information into the list. So in order for us to add into the list, we have to check first, does the list exist or not, or is it empty? So to check that, we will use condition. So we'll have an if and else. Okay, so we have to check whether the list exists or not, because since it's a linked list, it can be empty, it can be a list that consists of maybe 10 or 15 nodes, we don't know. So the condition would be to check. How do we check? Every list has a 8 pointer, which is the start or the starting node of the list. So we can check with the condition of the 8 pointer. So if the 8 pointer is null, it means that there is no list. Okay, so if there is no list, then this information from this new pointer will be our starting of the list. So what we need to do is, since it's null, so we will assign the new pointer to be our 8 pointer, and of course once this become the 8 pointer, remember that there's one information where it has to inform or the pointer to the next element. In our case, these are the first information, so there is no 8 pointer and there's no list. So what we have to do is we have to set the new pointer, the element for the next. Okay, since it's not pointing to any node or data in the list at the moment, so we will set it to null. Okay, that is if at all there is no 8 pointer, so that means there's no list, so this will be the first. But say if the list already exists and we need to add this node into the list, the question say insert at the beginning, right? So since it's insert at the beginning, what we have to do is the new pointer will become in front of the 8 pointer. So to do that, we will set the new pointer to the next that it will point to the 8 pointer. Why? Because the 8 pointer already exists. We are adding this node in the beginning of the list. So the list is already there, but we don't know how big is the list. So since the list is already there, then 8 pointer is definitely there. So we're going to put this allows, or this makes the new pointer to be in front or in the beginning of the list, because the next is pointing to the 8 pointer. Okay, so once we have done that, so now we know that we have placed the new pointer in front. So the current 8 pointer is no longer the 8 pointer. So what does this mean? The 8 pointer will now be the new pointer. Okay, so this is for entering a new node in the beginning of the list. If it's in the end, in this condition, for this else condition, what you have to do is basically you have to traverse or find till the end of the list, and then from the end of the list you put the next pointer of the end list will point to the new pointer, and then the new pointer to the next will be equal to null. That is for end of the list. But if it's in the middle, then you have an extra work where in this condition you have to ask the user, where do you want to put or place the node? Because it's middle, right? It can be anywhere from after the first node or node minus 1 from the end. Okay, so it's the same, but just the condition will be different. Okay, so now we have completed for the enter new event, so we know that it adds in the beginning of the list. Okay, so this part is already done. Let's do a quick error checking. Okay, everything looks good. Okay, now we'll move to the second process, which we have to list all event. So this function, what happens is that we have to print exactly as in figure 4.3. So we have to print the room number and the event. Okay, so here what we have to do is, of course, when the user calls this option, if you remember earlier I've mentioned that in the menu the user can select any one of these, right? So if the user decided to select this first, there's no list, so we're supposed to do an error checking on that. So the first thing will be the condition. So same as above, we're going to use the if else to check whether if the list exists or not. Okay, so how do we do that? By actually checking, like I mentioned earlier, the 8 pointer. If there's a 8 pointer, that means there is a list. If there's no 8 pointer, then there's no list. So the condition for this if will be to check for the 8 pointer that it does not equal to null. What does this mean is that if it's not null, the list is there. So then we will print out exactly what we want to print. But if it's null, then we will notify the user. So I'll reuse this printf. So we will notify the user that list is empty. Separate with two new line. Okay. So if it's equals to null, that means the list is not there. So we'll notify the user that the list is empty. Okay. So now let's focus. So once you've done the error checking, let's focus on how do we display all the elements or all the nodes in the list. Okay. So if you look at figure 4.3, okay, we have the room number and event. So let's reuse this code. So let's create a new line. We want to display room number. We are going to create this table. Okay, I'll use the tab. Okay, and then event is for the second column, and new line. Okay, so that will be the heading of our table. Okay, the next would be we want to start from the 8 pointer till the end of the list, because we don't know the size of the list, right? So this is where we will utilize this temporary pointer or the current pointer. So what we're going to do is we're going to assign or make a copy of the 8 pointer to the current pointer. So the current pointer will be pointing to the 8 pointer. Alright, so we know this is the start. So once we know it's a start, we want to traverse throughout the list, but we don't know the size of the list. So if we want to loop and display all the elements of the nodes in the list, we have to use while loop. So in our case, before we check the condition, so I'm going to use do while. You can also use while, it's fine, but in this example I'm going to show you with do while. Okay, so what we want to do is basically we want to print the data or the element inside of each of the node. So we will be using printf. So what are we going to print? Since our table heading is room number and event, so we are going to print room number, which is in decimal, and I'm going to put two tabs to keep a distance so that the column will match. Okay, and then the event is in string. Okay, and for each of it has to go in a new row, so there'll be a new line. Okay, so the two elements that we have to display, since we are using the current pointer to traverse around, so it will be from the current pointer, and the first element is basically room number. The second element is the event. Okay, so we're going to do this. So what would be the condition? How do we know that we need to stop? The condition would be basically when the current pointer that points to the next pointer is null. So as long as the current pointer does not equal to null, then we will loop this till we complete the entire linked list. Okay, so just to make it nicer. So I'm going to add another printf to display that it's the end of the list. Okay, end of list. And let's separate two lines. Okay, another part is in the loop. Of course, we have to add the terminating criteria. So we have that current pointer does not equal to null. Okay, but we have to add for us to traverse, which is current pointer equals to current pointer of the next. Okay, so what happens is that it will print out the room number and the event of the current node, and then it will keep looping by moving into the next until once it found it's null, then this loop will terminate. Okay, so that's for the code. So we can run and test this based on the sample of the figure 4.3. Okay, now for the testing, we will follow exactly like in the lab exercise 4.3. Okay, so the first choice, we will create a new event, but let's test the others. So by choice L, the list is empty, as you can see, and then if I put X, it will exit, but we don't want to close that first, so we want to test with the new event. Okay, so enter room number, so you'll key in room number 6, event name is conference underscore A. Okay, and then we will add more, room number 8, event name is training underscore I. Okay, let's take a look. So we'll put the L and check out the list. So as you can see, the list, we have the conference A and training I. So we will continue adding more into the list. Room number 5, which is for workshop Y. Okay, we'll add in more. Room number 3 for the meeting underscore X. Okay, just ignore this because my keyboard enters quick, so yep, so it actually checks, like when I do a single enter, it's actually, it goes double. All right, let's take a look again. We have entered up to meeting X, so we have 2 more. Okay, so we will add in for room number 2, which is workshop underscore J, and finally room number 10 for VVIP. Okay, this is what's shown in the figure 4.3. So let's click L and view the list. So there you go, this is the list. Okay, so we have exactly as in the figure 4.3. so you can test around. This is for insert in the beginning. Alright, if it's insert in the middle and insert in the end, you just have to change the condition statement, where if middle, you have to get another input from the user asking where, in which location do they want to insert the new node or the information. Alright, so okay, that's all then. So X, and we will exit.